Number two. Number twos are in logarithmic form. If you want to change that to exponential form, okay, put it in exponential form means write the same thing, not using logarithms, using exponents, which means I don't want this to be here. How can I get rid of that? If that's the key you were using, or that's the function you're using, log base 3, what would the inverse of that be? Well, it would look like this, right? 3 to the x. We're calling this anti-log, for lack of a better, base 3. Anti-log base 3 means saying, if I want to cancel out this log base 3, the way I cancel it out is by raising that side 3 to the power of what's on that side. It should be equal to 3 to the power of what's on that side. You know when we were solving equations by just equating the bases? Go down here for a second. Like the questions you made up right at the beginning of class today. 2 to the x equals 8. You're just equating you're writing it like this and saying if I have two powers, these have to be the same. Really what you're doing there is you're using logarithms even though you don't realize it. We're going backwards now. We're taking something that's not and making it into an exponential expression. The way you would do that is to say, well, if x equals 3, then 2 to the power of this side is equal to 2 to the power of that side. You're working backwards. Using the anti-log is working backwards here. So if log base 3 of 81 is equal to 4, then 3 to the power of log base 3 of 81 should be equal to 3 to the power of that. The reason why you do that is what happens with these two things here. 3 to the power of log base 3, what do those two operations do to each other? If it was on the calculator, think about how it would be written on the calculator. It would be 3 to the power of log, I don't know how they'd write base 3 here, but of some number, 81. What would these two operations do to each other? Just like square root of something squared. They cancel out, right? If you have if you have 3 to the power of log base 3 of 81, it's the same as just having 81. 81 is 3 to the 4th. You can change something to exponential form by doing the anti-log of both sides. It works on any of these here. This one is in logarithmic form. How would I cancel out that logarithmic expression? I'm going to do anti-log base what? What base would I use here to cancel out this? This is the logarithmic function I'm using, log base k. So you're going to use anti-log base k. If I do k to the power of what's on both sides here, can't really fit it in, but k to the power of this is k to the power of that. I'll rewrite it here. K to the power of h is k to the power of log base k of t. What happens here? K to the power of log base k cancels out, and what do I just have there? T. And don't worry that it gets big. That's just how it is. Evaluating these expressions here. Log base 3 of 3 to the power of. Now with your newfound hopeful understanding of these operations, log base 3 and 3 to the power of, what's that the same as? Yeah, just 5, right? If you have 3 to the 5th, and I say, what's the log base 3 of that? It's just 5, right? Because it already is written as 3 to the 5th. So that's what it is. That exponent is the logarithm base 3. What power of 3 is that number? Well, it's the 5th. For these other ones here, you need to think about it in terms of what power is it. If you're saying log base 6 of this, you're saying what power of 6 is it? What power of 6 is that? It's a half, right? If you're not sure, then just think, well, root 6 is equal to 6 to the 1/2. So that's what its logarithm is, that power right there. This you're going to need to practice with watching me do it is not gonna lend itself to understanding. All right. There's other ones here, and don't worry if you get to this one. I like to throw these kind of things in here to have for people who get to that point, but not everybody needs to be able to do this. Okay, so if I've put in there that it's a higher level thinking question, right now I want you. I mean, this is almost one here too. Although, if you want to evaluate what logarithm it is, what we need to understand, if you want log base 2 of something, you need to know what power of 2 it is. So you're going to have to change that to a power of 2. That's almost a higher level thinking question right now at this point, I would say. Can you get the practice booklet out and try some of the stuff related to this? Work on it for a little bit, and then we're going to come back and look at 2, 3 together in about 10 minutes or so, I would say.